In this video, we're going to learn about significant figures. What significant figures do for us is they tell us the level of detail to which we know a measurement. So when we're in the lab and we're recording measurements, we use things like graduated cylinders, rulers, or whatever. And when we're reading them, we need to use the markings to get information. So let's take a look at a couple measurements right here. We have a blue mark and a red mark. The blue mark, we can see, falls between 7 and 8. So we know for sure it's 7 point something. And looking at it, you can see that it's 1, 2, 3, 4, 5. It's 7.5. Now, whenever we're recording a measurement, we always approximate one digit or estimate one digit. So since I think that's right on the line, I'm going to call it 7.50. So all three of these numbers tell me something significant about the measurement I'm making. Now, on the red mark, we know it's between 7 and 8, so definitely 7 point something. And we know it's between 7.0 and 7.1. I think it's about halfway in between, so I would report that as about 7.05. So these would be measurements we would make, and all of these numbers here give us some level of detail about that information. But sometimes you're not necessarily the one doing the recording of the information, and you're given a problem where you're provided a number that you need to work with to find some answer. So there's a couple rules we've got to follow when we're doing that. One, any non-zero number is going to be significant. It tells us some level of detail about a measurement. But zeros, they can be a little bit more complicated. So there's two rules you need to remember when deciding whether or not a zero will give you some level of detail that you can then use in the calculation and incorporate into your calculated answer for something. So the two rules are the zero must either fall between two non-zero numbers or significant figures, or they can be after a non-zero number and there's a decimal present. So let's take a look at a couple examples and say whether or not the zeros tell us anything, and then we'll talk about why. In this first one counts, 2 counts. Obviously, they're non-zero numbers. This 0 follows Rule 8, falls between two significant figures, so yes, that 0 counts. Now this one, it falls after the decimal, which doesn't always count. But since there is a decimal present and it's after a non-zero number, we would count it. So all 4 of these numbers are significant, so we have 4 sig figs in that number. And you could use and provide 4 digits worth of detail in any calculation you do. The next one, number 2, if we look at that, we have a bunch of zeros in front of a 3 and then 3 zeros after. Well, these zeros definitely don't fall between non-zero numbers, or sig figs. And there's a decimal present, but they're not after a non-zero number, so they don't meet criteria D either. So none of these count. And they're really, and then you're like, well, why are they there? Why can't I just slide the decimal point? They're really just a placeholder, but they don't tell us the level of detail of how precisely we know a measurement. These 3 zeros that come after, they're after a non-zero number and a decimal is present, so all of those would count, and you would say that there's 4 significant figures there. Now, why do we do that? Why do we say those first 4 don't count? Well, if you look at this measurement right here, we were using a centimeter ruler, let's say. So it's 7.50 centimeters, 3 digits worth of information. If I were to convert that to the unit of meters, essentially since there's 100 centimeters in a meter, I have to slide the decimal 2 places to the left. So that becomes 0.0750 meters. Now, we didn't just all of a sudden magically, by converting to meters, gain 2 digits worth of information. That doesn't happen. We don't have 5 digits worth to work with. We don't have that kind of detail. So that's why we call those placeholders. However, this 0 counts because, again, it tells us that it falls directly on that 5 0 line. So the zeros after the non-zero numbers count, the ones before don't when a decimal is present.